plotting point techniques, we can plot these points. I hope the screen is visible to all.
Yes, ma'am.
Yes, okay.
Yes, ma'am.
Okay. Now further, in addition to this, we also can say, so this information as I suggested is not very clear from the given points. So for this we need to first convert it to the Cartesian form, and after conversion to Cartesian form, this I had discussed yesterday also. This represents a circle of radius 3 by 2. Center is 3 by 2 0. So that also we saw, and therefore we can conclude that it is going to give us a circle. Okay. Now there is another way of doing or sketching such graphs in case you are not able to convert it to Cartesian. It may not be straightforward for you or easy for you to convert every polar equation into the corresponding Cartesian. Okay, or it may be that you may have converted it, but it is a very complicated form. Okay, so then how do we do the graphing? So one thing is always plotting points are there, but in addition we also need to be having some idea about the shape. Okay, because plotting points is only going to give us the points, so it will not give us how it is shaped. And for that we will just use another way out. So first thing which we'll do is we will plot the graph as an equation in the rectangular system. Okay, so here we have a rectangular system where we do not have angular lines and circles for r and theta, but we have the xy coordinate structure here, where along the horizontal axis you are denoting theta. Okay, r is dependent on theta, so your independent variable is theta and your dependent variable is r. So r is represented along the vertical axis, and then treating this equation uh, like a equation in the rectangular system. So we are going to plot this. So you know how cos theta is graphed. Okay, so it graph of cos theta starts from 1, it becomes 0 at pi by 2, then minus 1 at pi, then at 3 pi by 2 again 0, and so on. So 3 cos theta will be 3 times that value. So you will start with 1 and then come to 0 here, then minus 3 at pi, then 0, 3 pi by 2, at 2 pi it is plus 3. So this is how your cos graph behaves, 3 times cos of theta. Okay, so once we draw this graph, we have some information about the shape or the behavior. That is, firstly, when theta is 0, r is 3, so which corresponds to this point. This is the first point which we took here, theta 0, r 3. This gives us the first point. After this we see that when it is increasing, when your value of theta is increasing from 0 to pi by 2, the value of r, which is 3 cos theta, is decreasing from 3 to 0. Okay, so the value reduces from 3 to 0 as your theta changes or varies from 0 to pi by 2. So this is the next point which is given here, and therefore we can get an idea that okay, it starts from 3 and then the values are becoming smaller. Okay, so this distance from the pole is reducing. Okay, and it reduces to 0. So as your theta becomes pi by 2, the value of r becomes 0, which means it comes to the pole. Is the first point clear? This one? Yes? Okay. The next point here,
Can I continue?
this point. See, this point says, if you look at the graph, that when your theta starts from 0 and moves to pi by 2, your value of r is decreasing from 3 to 0. Okay, so 3 and then something smaller than 3 and then so on. So how do we depict this on the r theta system? Okay, this is the rectangular system, which is not the actual one. The actual grid is like this. So how are we going to represent this characteristic of the graph on the actual grid? So you start from 3. When your theta is 0, your r is 3, and after that you start taking values which are closer to your pole. Okay, so you decrease your length of the line which is joining. So take smaller and smaller values. Okay, your r is reducing and it is reducing to 0. So that is how this shape comes here. Okay, you start with 3, then take something smaller, again little smaller, little less. So when you take values of r smaller and smaller, and ultimately your value of r becomes 0 when your theta is pi by 2, so you reach the pole. So that is how this shape is determined. Is it fine now?
Yes.
Yes. Okay. Next point, it says that when it is now changing from pi by 2 to pi, the values are negative. R, the values of R, they are negative, and they are decreasing from 0 to minus 3. So at pi by 2, the value was 0, which we have already seen. From pi by 2 to pi, when your theta varies from pi by 2 to pi, your R is negative. So negative means it will be pi by 2 to pi is this quadrant. Okay, it is the second quadrant, but because your r is negative, so it will be in the vertically opposite quadrant, which is this one. Okay, so instead of being in the second, it will now be in the fourth because r is negative, and here the values are changing from 0 to minus 3. Okay, so obviously minus 3 will be shown at 3 itself. So the values start from 0, then it is say 0.5, then say 1 at some point, then 1.5, then 2, then 2.5. So something like this is the behavior. It goes on increasing and then ultimately it comes to 3. So this is how you get the lower portion of your circle.
Ma'am,
Yes.
like in this method, we'll do like this. Now, first we'll fix the theta, and then we have to find the r. Then we have to plot it on the theta r1.
Yes. First you do the
So
plotting
isn't
on.
this longer than normal plotting because we are doing plotting 2 times?
See here, yes, we are doing plotting 2 times, but for some questions, this is more required than making this table. I mean, making the table again may not be easy for all types of expressions like this. Okay, so instead of having all these points, you just take the boundary ones like 3, 0, then minus 3, then again 0. So in between points, we are not checking here actually. Okay, we are not finding the values of the r for theta between 0 to pi by 2. We are just checking, okay, at, sorry, this is pi by 2. We just have seen that at theta 0, r is 3, then at theta pi by 2 it reduces to 0, then here it is further reducing to minus 3. So based on this information only we are making the graph. Okay, we are not using the exact values here. This was a separate thing to do. I have just repeated the table here so that we get to see some of the values which are the
So like the main point here is like we'll take less points.
yes, we
Like
don't have to
above
check.
we'll take
Yes,
7 to 8 points. Here we'll take only like the main standard values.
yes, the main ones where the behavior is changing basically. Okay, so like here at pi by 2 the behavior changes from being positive to negative. So looking at the graph, you mark the major points where your behavior changes. So here it is changing from being positive to negative. Then at this point it is changing from decreasing to increasing. Okay, here again from negative to positive. So these are basically your major changing points in the graph. Okay, so you just need to check at these points, and then in between you follow the behavior from here that it is decreasing. So the values of r are reducing. Okay, so somewhat decreasing shape you can make. So there is no fixed this thing as to exactly a circular shape, but somewhat like this would be a shape. Okay, so here we don't actually need all the points. So in case your graph is a very complicated one where calculation is not that simple for R, okay, and you are not able to find these points, so then you can go ahead with this technique and check for some major ones where you can easily find the value, and then in between see the behavior, how R is changing, okay, and accordingly you can make your curve. Okay.
Yes.
Okay. Now, next we move on from pi to 3 pi by 2. So when we move from pi to 3 pi by 2, it is changing from minus 3 to 0. Okay, but then if you look at this, so pi to 3 pi by 2 means it should be in the third quadrant. But because your r is still negative, that means we'll come back to our first quadrant. And here when I'm changing from 3 to 0, it is basically giving me the same branch. Okay, so after pi the points start repeating and you are going to get the same curve. Okay, it will be overlapping the previous curve which you have already drawn. So it is actually of no help to us. I mean, there is no requirement of doing the further sketching, but we just have to be sure that we are getting the same branch. Okay, and last is from pi to 3 from 3 pi by 2 to 2 pi. When we are going again, it is repeating the lower semicircle of this entire graph. Okay, so this is, there is a duplication in the movement of both these branches. Okay, so only first uh, till pi by 2 and then further till pi, only this much is sufficient to sketch the whole graph. Okay, but in general for every curve like this r equals to f theta curve, you need to check it till 2 pi. Okay, you should not stop it before that because there may be a different branch coming up, so we may not be aware of that. But for a circle we know that our complete circle can be sketched if we note the behavior from 0 to pi. There is no need to check the points beyond it. Okay, it is going to repeat the same. So is this process clear? We'll be doing more questions where we use this procedure. Okay.
So, ma'am, here we need to increase the value of theta and simultaneously plot the points, right? Whatever comes the value of r,
Yes,
right?
yes, yes. From 0 to 2 pi. I mean, that's a standard range which we usually check from 0 to 2 pi. But in case the question asks you for a different range, then accordingly you can proceed. Okay. Okay, this is another example. R equals to sine theta. For this again we have a similar symmetry check first. Here you would see that when you replace theta by minus theta, it is going to give you a different graph. So there is no symmetry about polar axis. But the second symmetry we can check here, that if you replace theta by pi minus theta, you are going to get the same equation. Okay, so here in place of theta, if you replace pi minus theta, then you will get again r equals to sine theta, and therefore this says that there is symmetry about theta equals to pi by 2, which is your vertical axis. Okay, theta equals to pi by 2. And second thing which we can make out here is that r is less than equal to 1. Okay, so this is another point. So the value of r will not exceed 1. Now if we convert it to Cartesian, so these types are all convertible to Cartesian. Again the same procedure, multiply with r on both sides, then replace r square by x square plus y square, and right hand side r sine theta is y. So we know this substitution, and then you have to just complete the square. Okay, so you add and subtract 1 by 4 and complete the square for y. X square is already there, I mean there's no need to do any other step for x, and then right hand side becomes 1 by 4. So that means it is a circle of radius 1 by 2, center is 0 comma 1 by 2. So that means center is lying on the y axis. Okay, or you can say center is lying on this line, theta equals to pi by 2. Okay, so I am not making the table for plotting points here, but these are a few points which you can check. So when your theta is 0, r is 0. When your theta is pi by 6, you will get half. Then at pi by 3, it is root 3 by 2. So these are simply your values of sine. So you can check that easily. That is why I did not make the table. When you put theta as 90, you get 1, and then again root 3 by 2, then 1 by 2 and 0. So till pi, if you take the values with these intervals or these points, if you take, you will get the complete picture. After that, the values will start repeating. Okay, so you will get the duplicate graph or curve, okay, which is going to overlap. So there is no requirement of checking points more than pi, but just to be sure, you can check it till 2 pi. Okay, just to eliminate the possibility of any other branches for any general graph. For sine theta cos theta, you will know that it is not going to exceed pi. Okay, but for other types of graphs, if you get any random graph here, then you need to check it till 2 pi, from 0 to 2 pi. Okay, so using plotting points, you can make a sketch like this. And when you convert to Cartesian, obviously you get to know that there is a circle whose radius is this and center is this. So you know the corresponding uh, coordinate of the center in the polar system. Your x is 0, okay, and your y is half. So using the conversion back, you can find the coordinates in the r theta system. So what will be the value of your r? R will be half. Okay, as in this r is not this r. I mean, this one is denoting the coordinates of the corresponding center. Okay, so this is half, and your tan theta is half. So which means what is your theta? Yes. Sorry.
Tan inverse 1 by 2.
Yes, tan inverse 1 by 2. Okay.
Ma'am, won't
Yes.
tan theta be not defined because it would be half by 0 y by x?
Okay, yes, that is what I was thinking here. So in fact that is infinite. Okay, so that means your theta will be 90. Tan theta will approach infinity, so which means your, or infinity itself, so theta is 90, which means your point is on this line. So if this is your r theta grid, so your point is on this line and it is at a distance of half. So if this point is at 1 units, half will be somewhere here. So this is your center. Okay, so if you refer back to your rectangle r theta grid, then you will say this is a circle whose center is on the line theta equals to pi by 2, and it is at a distance of half units from the pole. Okay, so you can just rewrite the sentence in terms of the polar coordinates.
So, ma'am, symmetric about theta equals to pi by 2 means that the center of that particular shape would be on that line.
Yes, half of it is on this side and half of it on the other side, symmetrically placed, mirror image.
Okay.
Okay.
So, also, yeah.
Yes, Dishita.
No, go on, Manat. First, you will ask. Ma'am, so first of all, we'll not consider these points. We'll convert it to Cartesian, and then we'll convert it to polar coordinates, and after that, we'll plot the center, and we have known in the Cartesian it's a circle.
Yes.
directly we plot a circle, right?
Yes,
It's
you
like
can directly plot the circle. So if you don't want to mark the points, then you can just convert it to Cartesian and get the information regarding the shape which you have, and correspondingly make the shape in the polar grid. Okay, whatever shape is there corresponding to this shape. So here you just have to interpret that if it is a circle with center at this in the Cartesian, what does it mean in the polar? Okay, so you just have to interpret this point in the polar system, and radius half would give you what, so accordingly you can mark your center and make the circle. Okay, so then there is no need to mark the points. Okay, is it fine, Mane?
yes, ma'am.
Yes, Dishita?
Ma'am, radius is half, right?
Yes, radius is half.
Ma'am, I was just asking, the y which you have, like the converting to Cartesian, r sine theta is equals to y. How? Like
R
how?
sine, that is the relationship we have. What is, how do you relate
Okay, okay, got it, got it.
X
Okay,
and
ma'am.
Y?
Okay. I'm also like, what is the purpose of this question? Are they going to ask you just to plot the graph of so and so polar coordinate?
Yes, yes. You will be given any graph r equals to f theta, okay, any function here. So, I mean, we are studying different possibilities which we can have for the function. So, if it is cos, then how your graph looks like. If it is sine, then how does it look like, okay. So, we'll do different categories of functions. We'll not do any random function. If I ask you to plot, say theta r equals to say sine theta plus theta square minus say 4 tan theta, so something like this you are obviously not going to get. Okay, so you will get some standard graphs which behave in a certain manner, and you will not be asked to sketch any such type. So this is the category where we have circles, and we'll see what type of functions for f theta are going to give us circles. Okay, so one category we did earlier was a category of spirals, then this is a category of circles. Okay, so like this we have few more categories which we'll do, and we'll obviously not take up any general graph like this. Okay, that's not possible. And if you in any case get something which is very different from what you have done, the best way to do is take the points and mark the points and then join them. Okay, that's the only way out. Is it fine, Dishita?
Ma'am, we won't be getting
Yes.
any polynomial graphs, right?
No polynomials. No polynomial. I mean, according to your syllabus, only r equals to theta, if that is what you call a polynomial type. So that is the only type of expression which you are going to get. And last year there was another one which was asked in the paper, that was r square equals to theta square. So this was another category which had come, but I mean this is following one of the categories which we are going to do, so it is based on that. So once when I do the graphs of the functions r square equals to some function of theta, so you will see what procedure we follow and how we solve it. And once you know how to solve such types, then you can also solve this type. Okay. So, but other than this, you won't be asked for the, I mean, spiral shapes, you know how your polynomials look like. They are all spirals. So, any such linear expression, if you have r equals to some a plus b theta, this type of expression you can do. Or further, if you have r square equals to some square, okay, you should have some square here, then you will get an idea. I mean, once when I do r square equals to f theta graphs, then you will get to know how this thing can be solved. Okay, so this is the different type which we can do. Okay, can I proceed now? Sorry. Okay, can I proceed? with this question. Okay, so these are the various types of circle equations which we can get. One is r equals to a. This is the first type which we have seen earlier also, that when you take r equals to a and have no restriction on theta, you get one full circle whose center is at the pole, radius is a units. Okay, so this is any point on this circle whose coordinates will have r coordinate always will be a. For any point on this circle, the r coordinate, radial coordinate, will always be equal to a. Okay, so this is one type of circle which you can have. Then second category, when you have 2a cos theta as your equation, which means you have a cos theta multiplied with some scalar. So when you have such type of expressions, then your circles will be having their centers on the polar axis or theta equals to 0 line, and radius will be equal to half of this number. Okay, so center will lie on this line, radius will be half of this number, and obviously this is the diameter. So you will start from here. Theta equals to pi by 2 will serve as your tangent to your circle. Okay, so if radius is half of 2, I mean 2, it is a, so your center will be located at a units from the pole. So center coordinates will have radial coordinate as a and the angular coordinate will be 0. Theta is 0 for this, so the coordinates of this point will be a comma 0. Okay, this is the center for such type of circles. So any scalar multiple of cos theta will give you a circle. Then any multiple of sine theta will also give you a circle, but center on the line theta equals to pi by 2. Center coordinates will be 0, your r is in terms of r theta. Your r will be a in this case, theta is pi by 2. So coordinates of the center will be a comma pi by 2. Radius is a units, this length half of this, and this line theta equals to 0 is going to be a tangent to this circle. Okay, so this is including all such questions where you have any scalar multiplied with sine theta. So remember here the angle is only theta, no other multiple of theta we can take here. Okay, only it is cos theta, and here we have sine theta. So no other term is going to give us circles. We will get different shapes if we either change the angle, take some multiple, say if I take cos 2 theta, sine 2 theta, something like that, then I'm going to get a different kind of a shape which we'll see later. Okay, but these shapes are going to give us circles, and for different values of a, when I, so say I take some a, I get a circle whose tangent line is this. If I have 2a cos theta, tangent line is this, then you increase the value of a, you get a bigger circle, again tangent line is here, and your center would be somewhere here. Then so like this the centers are going to change. Okay, so all these will have different centers, and increasing values of a will give you bigger and bigger circles. Okay, tangent line is this only, so every circle has to touch this line. Okay, and similarly for 2a sine theta, this is the family of circles which you can get for different values of a. Okay, so every time your line theta equals to 0 is going to serve as your tangent line. Okay, is this clear till here? This is a like a summary for all the circles. Okay, so is this part okay? Okay, I'll move on to okay, so regarding symmetry test, there is one additional type of condition which you can check. So earlier when I had mentioned the tests for symmetry, then I had only said that replace r theta by r minus theta, then you get symmetry about x axis or this line, basically theta equals to 0, polar axis. Okay, then there is one more change or replacement which you can consider, which is replacing r theta by minus r comma theta pi minus theta. So you need to change both r and theta to these two expressions, and if again you have no change in the equation, then you get the same kind of symmetry. Okay, so there are two different ways in which you can check for symmetry. So for the circle equations, the first technique was sufficient, and we got the condition for symmetry. But for some graphs, you will see that checking the second type of condition will also be useful, and it is going to give you some symmetries for different types of graphs. Okay, so both these conditions can be used. Either replace only, change only theta to minus theta and check if there is a change in the equation or not, or second technique is replace both r and theta by these two expressions and see is it changing your function or not. If it is not changing, then again there is symmetry. So symmetry can either be governed by first type of replacement or second type of replacement, but you should, I mean, only one of them will work for any one question. Okay, so you can check these. Then second, replacing r theta by r pi minus theta we had already seen. So this is an additional condition which also can be checked, that in place of r theta, if you replace it by minus r minus theta, then in that case you may have, if there is no change, then there is symmetry about y axis, and origin, it is the same condition which I have given. So this is one additional pair of conditions for these two symmetries, which you can note down. Okay, which will help us for some different type of questions. We'll just see. Okay, meaning of symmetry is the same. Symmetry about x axis meaning this line, and y axis meaning theta equals to pi by 2, this line. So in case there is some kind of a symmetry in this manner, then you will have your mirror images in this way. Okay, so and symmetry about origin, as I had also mentioned, that if these two symmetries are there, then it will imply symmetry about origin. So there is no need to check this independently. You can just check the first two and say that there is symmetry about origin. Okay. Okay. So this is the other type of graphs which are going to give us rose curves. These curves are called, or functions are said to have rose curves when we sketch the graph. So firstly we are checking for symmetries. Here the first kind of symmetry is achieved by checking the condition which I have just stated. Replace r with minus r, theta with pi minus theta. Okay, so use this condition, r by minus r, theta by pi minus theta. So in place of r you have minus r, then 9, then sine of 4 pi minus, this will be 4 pi minus 4 theta. So 4 pi minus 4 theta, where does it lie? What will be the sign for that?
Positive.
No. It will basically be checked in the fourth quadrant, 4 pi minus 4 theta. So that is why the sign is negative here. Okay. So we have a minus sign on the left side and minus on the right side, which gives us back the same equation. So there is symmetry about the x-axis.
Ma'am,
Yes.
ma'am, can you please repeat this? How we get minus?
4 pi minus something you have here, say theta 1. Okay, so if we have some expression like this, where is it going to lie? It is going to lie in the fourth quadrant. 2 pi means here, and then again another 2 pi.
Okay, ma'am.
Okay, so it will be here. So here your sign is negative, so that is why there's a minus sign. Okay,
Ma'am,
second,
won't it be easy that we only replace theta by minus theta in this?
theta by minus theta. Okay, that also is going to give you, yes, okay, that is also fine. Okay, and for the second symmetry, if we replace r and theta by both the negatives minus r and minus theta. No, but here if we replace theta by minus theta, we are going to get a minus sign, isn't it? Sine of minus whatever theta you have here is. So that is not giving us the condition for symmetry. We'll not get the same equation. Is it fine?
Yes, ma'am.
That is not
Ma'am,
going
but
to
one
help.
question that if it is symmetric about x-axis, so there are two chances that the first would be replacing theta by minus theta, and the second would be replacing r by minus r and theta by pi minus theta.
Yes.
So both would imply that the graph is symmetric to x-axis. So, like,
Yes.
why is it happening that the first one is contradicting the fact and the second one is?
No, no. The condition says that either of the two, if they exist, will imply symmetry. Okay, either of the two conditions, if they hold, it is not that both should hold, or it is not that I mean only checking one is giving you the complete picture. So for earlier questions, that was sufficient for us, but here we have an additional condition, okay, which is telling us that even if this replacement is going to give you no change in the graph, then also there is a symmetry. Okay, so it is not that both will hold for the same question. It may be that only one of the conditions hold, but there is symmetry. So if either of the conditions hold, then you will say the graph is symmetric.
Okay, ma'am.
Okay, and in the second condition also it is the same again, that if this kind of replacement or the other kind of replacement, whatever is giving you no change, if there is I mean one of them is giving you no change in the equation, then that means there is symmetry. Okay, so here this condition is helping us. If we replace r by minus r and theta by minus theta, both by minus values, then you see that you are getting the same graph, and hence there is symmetry about y-axis. Then third symmetry is already, I mean we need not check it, but even if you want you can check this, you will get the same equation. So there is symmetry about origin, or you can also say first and second symmetry implies symmetry about origin. Okay, so these two will yes.
So, like of those new symmetry conditions,
Yes.
only one of the both should satisfy.
Yes, even if one satisfies, it is sufficient.
But like if we check only, like for example, if we check only the first one,
Yes,
like the first half,
it may not
then
hold.
then it will not reflect the true picture. So we have to check all six chemistries for all.
Six, no. I mean, six is not required, four is sufficient, because you know, if these two are there, then it will imply the third one. Okay, so you just check four of them. So if two of them work, one from here and one from here, then it means there is symmetry about origin. Okay, and if one of them, one of these symmetries does not hold, then obviously this will also not hold.
Okay, ma'am.
Okay, so there is no need to check all six conditions, four conditions are sufficient. Out of those four, if two in that manner, like one is for x and one for y, if that holds, then it implies the third one, that there is symmetry about origin. Okay, so this was the symmetry part, and value of r, maximum value is 9 because sine of whatever angle we take is at the most 1. So this expression is having maximum value 9. So this is something which we can get to know from the polar equation itself. Okay, so this is the information we get to see from the graph. Now what else? We can also use plotting points and plot these points and join them. So that is another way out. Here there has been this technique which is suggested by some authors. They say that how to decide how much gap you should take. Okay, so this is an ideal way of checking how much gap. You take your 4 theta equated to pi by 2. What is the 4 theta? 4 theta is the angle that is coming up here along with sine, whatever is the argument of sine, that is your 4 theta. So you may have any multiple here like 6 theta or 10 theta or something like that. So equate this to pi by 2 and that gives you theta as pi by 8. So according to some authors, this is an ideal gap for theta which you can take. Okay, if you are using plotting points, you can ideally take the gap to be this, because some change in the behavior is occurring at every pi by 8. So that is what they suggest. Okay, but it's completely your choice. If you want to take fewer points, 7 to 8 points as I suggested, you can do that, and you can accordingly make the graph. Okay, just give me a minute. Okay, so here when we take this gap, we are going to get these values. Okay, 0 9 0 minus 9 0 9, so on. So you can check this, or you can make lesser points if you want to. Now let's see how the graph comes out to be. Okay, so at 0 the value is 0, then at 9 it is 9, again 0, again minus 9. So although it is not very useful for us, the plotting points technique, but some idea we can get. Okay, and when we make the graph in the r theta rectangular system, okay, when we take the rectangular system, then if we make the graph, we can see that there is some change happening at pi by 8. So you can make out this more clearly when you are making a graph of this type. Okay, using your horizontal axis for theta and vertical axis for r, you can see this is the behavior which you get, and the behavior changes at every pi by 8. Okay, so 0 to pi by 8 it is increasing to 9, from 0 to 9. Then at pi by 8 the value starts decreasing, so there is a change in the behavior, and it decreases to 0. Then after pi by 4 till 3 pi by 8 it is negative, and it is decreasing from 0 to minus 9. Then it starts increasing, but it is still negative, so it increases from minus 9 to 0. Again it is increasing from 0 to 9. Then so the behavior starts duplicating. So one unique branch you can find till this point. Okay, after this point it is again till here, maybe or maybe till here, till pi by 2 it is giving you the unique behavior. After pi by 2 it is again repeating, so you again have this shape. Then again it is, so after this it is starting repeating, and till 2 pi you can see it is repeating a lot of times. The same curve is repeating again and again. Now let's see if we translate this rectangular grid into the polar grid. Okay, so how do we make the graph? So from 0 to pi by 8, the value of r increases from 0 to 9. So at theta equals to 0, your r is 0. That means this is your starting point. Then when theta increases from 0 to pi by 8, so you have to make a marking for pi by 8, because there is a change in behavior after that. So you should know, you can use your D and mark the angle pi by 8, and at pi by 8 make some marking for length 9, because 9 is your maximum limit. So you can use your ruler and mark a certain length for 9, and your value of r increases from 0 to 9. Okay, so this is how your graph will be shaped. So basically this red branch which is coming here is now translated, or you can say the corresponding portion of your graph in the polar grid is going to be this red portion. Okay, where it is increasing from 0 to 9. So this red portion from here, I'm just as if I'm lifting this up from here and placing it here in this form, because here I have to show values increasing from 0 to 9. So when I'm increasing, it means every time the distance from pole is going to be bigger and bigger. Okay, so you have to basically make it like this, like a concave up shape. Okay, because your values are increasing, so there is no other shape which is possible. It has to be like this. Okay, next we move to the.
Ma'am, we only have to check for those angles on which the value is like fluctuating, right?
Yes, the graph is changing its behavior. Okay, so that fluctuating point you can get to know by equating this angle here to pi by 2. 4 theta equals to pi by 2. When you do that, you get theta as pi by 8. So that pi by 8 is telling you after how much gap the value is going to change. Okay, so that is.
This will not be possible with Cartesian method, right?
No, with Cartesian it is not going to be possible.
I think the most suitable is the plotting points one in this.
Plotting points also is just giving you these points. This is the best way to do, that you make the rectangular grid, okay, and then make the corresponding polar grid for this. Okay, rectangular grid, you make the graph, sine graph, you know how it behaves. At 0 it is 0, at pi by 8 it is going to be 1. This sine 4 theta will be 1, so 9 into sine 4 theta will give you 9, and so you know it is going to behave in this manner. Okay, so you can make the rectangular grid first, take the system, and then make the graph of an equation of this form, and then translate it to your polar grid. Okay, so this increasing, decreasing behavior, then again negative, then again increasing. So all this is going to help you with the sketching, because if you do not know whether it is negative or positive, or whether it is increasing or decreasing, then you will not be able to give the shape. Okay, how do I know the shape is like this? This is only possible if I know that my function is increasing. Okay, so initial value is here, then next value will be slightly ahead, then again slightly far from your pole. So every time you take a point, its distance from the pole is going to increase. Next point is having bigger distance from the pole, then next point is again farther from the pole. So only when you construct such a shape, I mean you have such an information, you can get a shape like this, that every time it is increasing, and it is increasing till 9. So put some marking for 9, so that you know 9 is this much, and you keep your graph stretching from 0 to 9 in a increasing manner. Okay, and at pi by 8 it is 9. After pi by 8 your function is decreasing from 9 to 0. Okay, and angle changes from pi by 8 to pi by 4. So next portion you take here, pi by 8 to pi by 4. Here your values are decreasing from 9 to 0. Okay, so first initially it is 9, then slightly less, then slightly less, and then so on. So you keep on decreasing the distance from your pole, and then finally reduce it to 0. So this green portion basically comes here like this. Okay, is it fine till this part? So for any curve in general, first thing which you should check is symmetry. Okay, and the range if possible. If you can find out the upper limit for r for that given graph, it is well and good. Otherwise it may happen that your r is not bounded on the upper side, so then that condition cannot exist, so you don't have to give it, but otherwise you can give that condition. Okay, it is time for the class.